Okay, so today we're going to go over pH scale and how changes in pH can be either measured quantitatively or, in the case of looking at indicators, being able to determine whether or not it is an acid or a base. So when you look at the pH scale, you can see below, on your notes is a better representation, but on the bottom part here we have this thing called the hydronium ion concentration. And what happens is it'll go from 10 to the 0, which is 0, all the way up to 10 to the negative 14. And as you can see, that's actually 1, will be a lot more than 10 to the negative 14. That just means that this is going to be 0.000 all the way to 14. Okay. So when you look at the pH scale, the one that's going to have the most hydronium ions are going to be the ones that are most acidic. So that scale, if you take a look back up here, that scale 0 to 7 is going to be the pH scale. So we can also compare 10 to the 0 all the way up to 10 to the negative 7. All the way up to 10 to the negative 14. And again, what this is measuring, it's measuring the hydronium ion concentration. Okay, and you can see that there. You might see it also as a proton. And again, just to recap, these two things are synonyms. pH, by definition, stands for the power of hydrogen. So just put power or potential. And see that it is a lowercase of hydrogen. And it's usually a hydrogen concentration, which we show by using those brackets. So we know for acids, we say that acids have a low pH. So that low potential to attract hydrogen ions. And again, that means it's going to release or donate those hydrogen ions. Bases, on the other end of the spectrum, would have a high pH. Again, 7 to 14 would be its range. So that means it would have a high potential to attract ions. So we call those, acceptors. The interesting thing about the pH scale is that it's logarithmic, meaning that one pH unit is 10 to the 1. So that's 10 times the concentration factor. So as we go from, say, 10 to the negative 1 to 10 to the negative 2, that is a change in the factor of 10. Okay. So the relationship here means, we say the low pH means there's more hydrogen ions. Okay. And that's what makes this an acid. High pH means less hydrogen atoms. So let's just take a look at that. Just talking about hydrogen ions, we can see the larger amount is here. Okay, 10 to the 1 is roughly 1. And as we go from left to right, we're getting lower. This would be a pH of 4. This would be a pH of 7, 10, and so on and so forth. So the ones that have the lower numbers actually have the higher concentration of hydrogen or hydronium ions in solution. Okay. The key to this is when you look at this, you have to be able to say, well, is it more basic, less basic, increasing acidity, decreasing acidity? So when we take a look at this, pH-wise, if we're going to add an acid, the pH is going to decrease. Okay, so adding acid is going to increase acidity. So increasing acidity means that the concentration of hydronium ions or hydrogen ions are going to increase. So as we're decreasing, as we're going this way, what can we see is happening to the oxygen or the hydroxide ions? Decreasing. So in the case of when we add an acid, it's becoming more acidic. In the case of bases, we know that the number, so I'm going to just highlight it over here, the pH is increasing. We're going from 7 to, in this case, 14. Meaning that as we go across there, our hydroxide ions are increasing, and the red part, which is your hydronium or hydrogen ions, are decreasing. So we say that this is becoming more basic. And you might see the word alkaline, which indicates that it is becoming more basic. Now, interestingly enough, like we said before, the changes in pH are tenfold. So if I go from 1, like a -1 to a -3, I have gone up 10 times 10, which is 100 times the fold. Okay, so let's just take a quick look at this. If we're looking at, I'm going pink, we'll make it pink. A hydrogen ion concentration, each pH unit is a factor of 10. So if I'm going to increase the pH by 1, that is a factor of 10, which is the same thing as writing 10 to the 1. Okay. Increasing or decreasing by a factor of 2 would be 100 times. Okay, so you might be able to see this as, let's say we're going from a pH of 1 to 3. If I go to 2, that's 10. If I go to 3, that's another 10. So 10 times 10 equals 100. Or we can use the tens and scientific method to kind of help with looking at what this means using exponents. So another way to write 100 would be 10 to the 2. So if I'm changing by a factor of 2, I can use that as my exponent with talking about factor of 10. If I go by 3 changes, and you might also notice that the number indicates the number of zeros, 1, 2, 3, it's showing you that it's going up by factors of 10. Remember, it's always 10 times 10 times 10, not, oh, it'll be 30. Okay, factors mean multiplication. So let's describe what would happen if we were to change the concentration from 7 to 5. So let's do the math. 7 minus 5 equals 2. So I'm going to take that and I'm going to go 10 to the 2. That's 100. And it's 100 times, because it's a factor, has it become more basic or more acidic? From 7 to 5. It's going to be acidic. What's happening if we're looking at the concentration going from 5 to 8? So let's do the math on that. That's a factor of 3. So I can take that, put that into my exponent, and that's going to be 1,000 times. I've gone up the scale, so I would say 1,000 times more basic. Hope this helps.